The Supermarine Spitfire, I mean, what a legend. It's often called the most perfect aircraft ever built. But why? What was the real secret behind that perfection? Was it just one single thing, or was it a whole bunch of hidden innovations working together? Well, we're going to dig in and find out.
Think about that for a second. Don't touch anything, it's perfect. Those were the very first words spoken about the Spitfire right after it landed from its maiden flight. Usually, a test pilot comes back with a laundry list of problems, right? The rudder's a bit sticky, the engine's running hot, but not this time. Just a stunning, simple verdict. It's perfect. So, okay, that's where we're going to start our investigation.
So, how does a plane earn the title perfect from day one? Well, to get to the bottom of that, we have to start with the man behind the machine, the visionary who dreamed it all up.
Meet Reginald Mitchell. By all accounts, a quiet, unassuming genius. And when I say genius, I mean it. He was chief designer at Supermarine by the time he was just 24 years old. He'd already made a name for himself designing these record-smashing seaplanes. But then, tragically, in 1933, he was diagnosed with terminal cancer. Now, for most people, that would be it. But Mitchell, he did something incredible. While gravely ill, he poured every last bit of his energy into designing this Spitfire. He literally designed it from his sickbed. And sadly, he passed away in 1937, just before he could see his creation become the legend we know today.
And it wasn't just the pilot who was blown away. You have to understand, military test reports are designed to find faults. They're meant to be brutally critical. A normal report would have pages and pages of notes on things to fix. So for the official 1936 test report on the Spitfire to begin with the words, "The aircraft is simple to fly and has no faults," I mean, that's unheard of. It's like a food critic saying a meal was flawless. It just doesn't happen. All right, let's get into the hardware. We're going to start with the Spitfire's most famous feature, that gorgeous, unmistakable elliptical wing. But its real purpose? Well, that's one of the biggest myths about this plane. So why the famous elliptical wing? You've probably heard the classic explanation, right? That it was all about achieving some kind of theoretical aerodynamic perfection, the perfect shape for the perfect wing. But is that really the whole story? Nope. The reality is actually much more practical and way more clever. See, the myth is that it was all for aerodynamic perfection to minimize drag. And look, an elliptical shape is really good at reducing a certain kind of drag. But the real reason Mitchell went with that shape, it was all about fitting everything inside. He had to cram in retractable landing gear, 4 machine guns, and all their ammo. The elegant curve of the ellipse was the perfect engineering puzzle piece that gave him just enough room to make it all work. It was a practical solution to a packaging problem, not just a beautiful theory. So, get this. The wing's famous shape wasn't actually its real secret weapon. The true magic, the thing that really set it apart, was something you couldn't even see just by looking at it. It was its absolutely radical, unprecedented thinness. Okay, let's put some numbers on this so you can see what I'm talking about. Take a look at the competition. The Hawker Hurricane's wing was 19% thick at the root. The German Bf-109, 16%. Even the legendary P-51 Mustang was 15%. Now look at the Spitfire, only 13% at the root. But the really crazy part is what happens as you go out towards the tip. It tapered down to an unbelievable 6%. Just 6%. Nobody had ever managed to build a strong, high-performance fighter wing that thin before. That was the real key to the Spitfire's ridiculously low drag and its incredible speed. Okay, but that brings up a massive question, doesn't it? If the wing was basically paper thin, how on earth was it strong enough to survive the insane forces of a high-G dogfight without just ripping off? Well, the answer lies with another genius, a man named Joseph Smith. He was Mitchell's successor, and really, he's the unsung hero of the Spitfire. He's the one who figured out how to make this impossible wing possible. He engineered this revolutionary internal structure. He created a super strong box-shaped main spar using layers of metal and combined that with a thick aluminum skin at the front of the wing. The result was what they called a D-box, an incredibly thin structure that was also unbelievably rigid and strong. It was a masterpiece of structural engineering.
And what did that mean in the real world?
Just look at these dive speeds. A Hawker Hurricane would start to literally shake itself apart once it got past about 640 kilometers per hour. The Spitfire, on the other hand, it was tested to a blistering 780, and it held together perfectly. That insane structural strength gave its pilots a huge, life-saving advantage in a fight.
Okay, so we've got an incredible airframe. But an airframe is just a fancy glider without an engine. And the Spitfire had one of the best ever made, the legendary Rolls-Royce Merlin. But of course, even here, there was another hidden secret that gave it a special edge.
It's all about something called the Meredith effect. So here's the problem with big, powerful liquid-cooled engines like the Merlin. They need huge radiators to stay cool. And those radiators stick out into the airflow and create a ton of drag. But back in 1935, a British scientist had a crazy idea. What if you could design the radiator's housing, the duct, in just the right way to turn all that waste heat into thrust? Essentially, what if you could turn your radiator into a tiny, primitive ramjet engine?
And that's exactly what they did on the Spitfire. Here's how it works. Air gets sucked into the duct under the wing. The shape of the duct slows it down and compresses it. Then it gets blasted with an insane amount of heat from the radiator. We're talking enough thermal energy to heat a 9-story building. This superheated air expands violently and shoots out of a nozzle at the back, creating forward thrust. And get this, at high speeds, that little push was enough to completely cancel out the radiator's own drag. It was like getting free horsepower. An absolutely ingenious piece of applied physics.
All right, let's recap. We've got a super low-drag airframe, an impossibly thin but incredibly strong wing, and a powerful engine with a zero-drag radiator. That sounds perfect already, right? But there was one final, crucial ingredient. A chemical secret weapon that truly unlocked the Spitfire's ultimate potential.
So the Merlin engine got a huge chunk of its power from its supercharger. Think of it like a giant air pump that shoves way more air and fuel into the engine cylinders than they could normally breathe in. More air and fuel means a bigger bang, which means more power. Simple, right? But there's a catch. If you compress that mixture too much, it can detonate uncontrollably, a phenomenon called knock, and it will literally destroy the engine from the inside out. The only way to safely crank up that supercharger and get more power was to have much, much better fuel.
And right when it mattered most, in 1940, during the desperate days of the Battle of Britain, the Allies had exactly that, a decisive chemical advantage. While German fighters were running on standard 87-octane fuel, Britain had just gotten its hands on a massive shipment of new, high-tech 100-octane fuel from America. And the story of where this super fuel came from is just amazing. It starts with a brilliant Russian chemist, Vladimir Ipatiev, who emigrated to the United States back in 1930. Working in the US, he's the one who perfected the process for making the special additives that made 100-octane fuel possible on an industrial scale. And that fuel arrived in Britain just before the Battle of Britain kicked off. It allowed Rolls-Royce to basically flip a switch, crank up the boost on the Merlin engines, and instantly find almost 200 extra horsepower. That gives Spitfire pilots a critical life-or-death performance edge right when they needed it most. So when you really look at it, the Spitfire's perfection wasn't just one single flash of genius. It was this incredible chain of brilliant solutions, one layered on top of the other. A pragmatic wing shape hiding a revolutionary structure. A radiator that turned waste heat into speed. And it was all unlocked by a chemical advantage pioneered by a Russian-American chemist. Which leaves you with a pretty amazing thought, doesn't it? Could one of Britain's greatest national icons have ever succeeded without all these hidden contributions from engineers, scientists, and innovators from all around the world?